All right, in this video, we're discussing the law of large numbers. So let's read it real quick. It says the law of large numbers says the proportion of favorable outcomes for an event obtained from a large number of trials should be close to the expected proportion and will move closer and closer as more trials are performed. So what we're saying here, simply put, is let's say this coin is supposed to be fair and it's supposed to turn up heads half the time, right? So the proportion of heads should be 50%. Well, imagine if you only flipped it 3 times. It couldn't be 50%, right? You'd either get 1 head, 2 heads, or 3 heads. In either case, that would not be ever 50% of the time because you only have 3 flips. Obviously, it's not even possible to get that proportion of heads. So what we're saying is, what if you flip the coin, though, thousands and thousands and thousands of times? Well, again, it's unlikely that, let's say you flipped it just 1,000 times. It's unlikely that you would get exactly 500 heads and exactly 500 tails. However, you'd probably get a percentage when you divided the number of heads by the total number of flips. You'd probably get a percentage that's very close to 50%. And then if you increase the flips to 10,000 flips or to 100,000 flips or 1,000,000 flips, that percentage would get closer and closer and closer to the 50% that it should be if indeed the coin is fair. So that's the law of large numbers. What I like to say to people is that essentially it's like, over time, if you make enough observations, reality will reveal itself. In other words, if that coin is truly fair and you flip it over and over and over again, eventually it will reveal itself to be fair. In other words, when you look over the arc of the times that you flipped it, you look over the long haul process or procedure, you'll say, hey, yeah, about half the time that turned out heads, right? Again, unlikely to be precisely 50%, as a precise answer. Like, in other words, if you flipped it 1,000,000 times, it's not going to typically turn up to be 500,000 heads, right? Because there'll be some randomness in the process. But when you divide the two numbers, the number of heads divided by the total number of flips, it's going to be very, very close to the 50% it's supposed to be if the coin is indeed fair. If you thought about it in terms of people, if somebody's trustworthy, right, it'd be hard to tell if they're trustworthy just from a few interactions. But if you interact with them day after day for years, then probably you will observe that they're trustworthy, right? Over time, their nature or their traits will reveal themselves. That's sort of what the law of large numbers is saying. Okay, so here again is a visual example of this. Let's say you toss a coin 4 times and it only turns up head once. The proportion of heads is only 25%. You might think the coin is unfair at that point, right? Because, geez, it only turned up head 1 out of 4 times. But it's only 4 tosses, so it's a little hard to see if, in fact, in the long run, it's really going to stabilize towards its 50% probability. Let's say you toss it 100 times, now 64 times heads. It's a 64% probability of heads if you work that out, right? 64 divided by 100. So again, looks a little unfair, but now it looks unfair in a different way. Before there were too few heads, now it seems like there's too many heads, right? Flip it 1,000 times, this number is coming down, it's 58.2%. They flipped it 10,000 times, and now they got 4,989 tosses that ended up being heads. As a percentage, it's 49.89%. Very close to 50%. And if they flipped it another 10,000 or 100,000 times, chances are this percentage would get even closer. In fact, the law of large numbers says that it will get even closer and closer to its true 50% value.